Today is the 13th. It is a Gold Friday, the 13th. Actual Thursday, but Gold Friday. And what are we doing today? So we're going to find some sides of some similar figures. So we talked about what similarity means in the last class. Somebody want to remind me what similarity means? I'm gonna give you a quick thing. Maybe we could put some notes here. Things that are similar have the same something but different something. What would?
Same shape, different size.
There we go. We were okay. I heard a bunch of different things, but some of them were right. So same what? Shape. Different sizes. And actually, if they can be the same size also, we'll talk about, that's a special case. We call that, when it's the same size and the same shape, then it's not only similar, it's also congruent. And we got a whole unit on congruence coming up later on. Same shape, different size. I also heard length. Length is the same as size, so if you said different length, that is also correct. Shape has to do with angles. That's going to come up later today. So we got similar figures. That means they're going to be the same shape, but they're different sizes. And we're missing a measurement on one. Now this comes up in the real world all the time when you're dealing with things like blueprints. You're trying to construct something and they've got some of the dimensions on there, but they don't have all of them. And you're trying to figure out some missing dimension that's not written on your blueprint. Guys, if you can't, I'm going to just ask you one last time. If you can't sit there and not poke at each other and not talk to each other, then move, or else I'm moving you. Okay? Feel free to do it preemptively now if you need to. Okay, so we're going to be solving for those missing sides, and the way we're going to do this is using proportions. Now, I'm going to warn you up front that there are more than one way to do this, and those of you who abuse the homework help on the assignments, we've talked about this before, that homework help is there as a backup. I know a lot of people, I don't think in this class I haven't noticed as much, but I've noticed a lot of people when as soon as they look at a problem, even before they read it, they click on the homework help. Because the homework help pretty much tells you how to do it. You guys need to be actually doing the problems and trying to do them on your own, and then the homework help's a backup. The homework help's going to show you a different way to do this, and I don't like that other way. It works about 75% of the time, and the other 25% it's going to give you a wrong answer. All right? So it's good, but I'd rather do something that works all the time, and proportions work all the time. We'll talk more about the other way later on. But let's talk about proportions today. So, and proportions, in case you forgot, that's what we did in our warm-up today. These equations with fractions on both sides of an equal sign, those are proportions. So we've already practiced solving them. Today we're going to use them to solve some problems. So go ahead and find, this is about halfway down the page where this one starts. Before we get into our learning target for today, let's take an opportunity to review some of our previous information. We're going to see transformations come up again and again and again, and it's a super important topic in Algebra 2 and pre-calculus and calculus as well. So we want to make sure we keep sharp on that. I would like you to describe, that means name me, some transformations that would take this small rectangle and turn it into this big rectangle. Just write the names of any transformations that you would need to do to turn this small rectangle into this big rectangle. Put them right here underneath where it says A. What transformations would you need to do to turn that small rectangle into that big rectangle? I'm going to help you, for those who are not sure or feeling a little stalled out. We've learned about 4 different transformations at this point. 3 of them are called rigid transformations. Those are rotations, reflections, and translations. Does this sound familiar? And what's special about rigid transformations? They keep things same size, same shape. And then the 4th one that changes sizes is called a dilation. And can we all agree that we're going to have to use a dilation to get this small rectangle into the bigger one? Dilation has to happen. Now, my question to you is, do you think we would need anything other than a dilation? Maybe a translation also. Like if I just made this bigger, it wouldn't overlap. I might have to move it over and down a little bit to make it overlap. So maybe a dilation and a translation. I think we could probably do it with a dilation and a reflection too, if we were careful about how we dilated and how we reflected. But for sure a dilation, right? We know that because it got bigger. And the only way to change the size of something is a dilation that we know so far. Now, you can actually accomplish this just with a dilation if you were to choose the right scale factor and you were to choose the right center of dilation. And I'm going to give you guys a moment here. This is kind of an extra spicy challenge. Could you find the point that you would need to use for your center of dilation to get straight from this to this without having to do a translation? I'm curious if anybody can figure out what that is. And I'm gonna try and remind you by going back to this dilation we did. I know it's been a while, but when we did this dilation, we dilated about this point right here. And we took this small quadrilateral. Actually, it turned out, I think that was a trapezoid. Was it? No, it's not. These are not parallel. It's just a quadrilateral. We took a small quadrilateral and we enlarged it by a factor of 2. But we did it about that point. Do you guys remember it was special? We drew these extra lines that I drew in pencil here. Those might be helpful to you. Do you guys remember that property of dilations? If you take a point and connect it from its old version to its new version and then keep drawing that line, that's always going to go through your center of dilation. Can you use that to figure out where the center of dilation would be for these two rectangles we're looking at? This is something that I would not put on a test. This is above and beyond, but I bet some folks in here would be able to figure it out. I'm going to put the solution up here. If you want to still let your brain be a little puzzled by this, don't look up here because spoilers incoming. There we go. That would be my center right there. Okay. Again, you don't need to worry about that. Here's what I do want you to worry about. We're going to make some proportions now. We're going to show that some ratios are equal. So I'm going to create a ratio. Now, a ratio is just a fraction. A fraction is one way to express a ratio. There are other ways too. I'm going to use a fraction here. Somebody give me a number from this picture. You got 4 options to choose from. You want to go 20? I heard 21 first, so I'm going 21. I'm going to put 21 on the top. Can you guys find me the corresponding side of the other rectangle? Corresponding means matching. I already heard the right answer a couple times. I heard 6. That is correct. Put that on the bottom. 21 corresponds to 6. They match because they are both the longer side of their respective rectangles. 21 over 6. Could you write me another fraction that would be consistent with the way we set this one up? Now, on this one, we did the bigger shape on top and the smaller shape on the bottom. So make sure you're consistent. Bigger shape on the top, smaller shape on the bottom. I'm getting 7 over 2. Is that what you guys came up with? I got a question for you. Are those two fractions equal to each other? Yes? You're telling me if you simplified 21 over 6 and you simplified, well, actually 7 over 2 already is simplified. If you simplified 21 over 6, you would get 7 over 2? Then they're equal. All right, and what does that fact that those two things are equal tell us? What that tells us is since they're equal, that tells us that these two shapes are similar. So we are confirming that those two shapes are similar. In order for two shapes to be similar, their ratios have to be equal to each other. By the way, in the homework help, they wouldn't write 21 over 6. They would write 21 colon 6. I don't like this. This is also a ratio, but fractions make a lot more sense to me than these. Okay. What other ratios could we use? What if we had not done the 21? What if we had chosen, for example, what if I chose the 7 to put up here? What would I put on the bottom? 2? 7 over 2, and then for my other, I'd have to be consistent. We did big over small, big over small. Oh, that's kind of the same thing we already did, isn't it? Okay, never mind. Let's do something different. What if we put the 2 on the top? Ooh, let's put the 2 on the top. That'd be different, wouldn't it? Put the 2 on the top. We'll go on the bottom. 7 corresponds to 2, so we could do that. And then we need to be consistent. 7 and 2 are corresponding. So give me 2 other corresponding sides, but make sure you get the smaller one on the top and the bigger one on the bottom. 6 over 21. It's basically the same thing, but we've just flip-flopped them, right? 6 over 12. Yep. Oh, got a little backwards there. Thank you. All right. Hey, check this one out. What if I went 2 over 6? Could you set me up another ratio that would be consistent with the way that I set that ratio up? On this ratio, I picked 2 sides from the same shape, and I did the smaller one on the top and the bigger one on the bottom. What would you do over here to make it consistent? 7 over 21. Tell me, are those 2 fractions equal? I put an equal sign in between, but I should have checked before I did that. So imagine that equal's not there, and then check it. Is 7 over 21 the same as 2 over 6? If you reduce those, you would come up with, this is 1/3, right? This is 1 over 3. And if we divide both of these by 7, it would be 1 over 3. Oh, they are the same. Okay, so it is equal. So which one of these is the right way? All of them. All of them. In fact, for any situation where we have similar figures, there are at least 8 different ways you can set up this proportion and do it correctly. But not every combination is correct. So let's look at an example. And so they're in part D here, they're trying to kind of get you to start thinking about some common mistakes with this. So Lynn is trying this out, and she says, you know what? I don't think they're similar, because she says, I got 2 over 7, and then so I use the 2 and the 7, and then I'm going to use 21 and 6, which are my other 2 sides, and I'm going to look and I'm going to say, are those fractions equal? And they most certainly are not equal to each other. And since they're not equal, that means they're not similar. But Lynn made a little mistake. And I want you to think about it for a minute. I want you to put yourself in my role as the teacher. Imagine Lynn is your student. You're walking around and you look at Lynn's paper and you're like, I think there's a mistake. What would you tell Lynn to help her fix her mistake? Don't say it out loud. Write it down on your paper. What hint would you give to help Lynn out here? Are you just playing on your calculator, or are you with us here? It's okay. We'll get back with this, though. You got this. If you were not with us in spirit a moment ago there, my question is, part D, Len set up that proportion there, and there's a mistake with it. So I'm trying to get you to look at that and see if you can figure out what the mistake is. This is an important question, because this is it. The stuff we're doing today, it is really simple to do. It is also really easy to screw up. Okay? It's one of those things that, like, once you learn it, you're like, oh, that's easy. That's a fraction over here and a fraction over there, and you cross multiply and solve. But when you go to set those fractions up, it's easy to make a mistake like Lynn did. Does somebody want to be bold and tell me, what would you say to Lynn if you were Lynn's teacher? What hint would you provide? What do you think? You got a good description going there. I like it.
They're not equal to each other. Like, I mean, like the top and the bottom.
Okay. I love that, what you just said there. I think that is a huge clue. Did you guys hear that? Lynn, in her 2 fractions, in one of them she put the smaller number on top, and the other one she put the bigger number. She put the smaller number, word for word you said she put the smaller number and the bigger number on top. Right? She's mixing and matching. Okay? That's great. That's awesome. Anybody have anything you want to add to that? Oh, I love that C word, consistent. Yeah. She's being inconsistent about, you guys said consistent too, I think I heard, yeah? She's being inconsistent about how she's setting it up. Now, when I look at this, there are two things you got to check, okay? And guys, don't miss this. This is one of the most important parts about today, okay? Again, I'm going to tell you this is really easy, but it's really easy to screw up. So you always want to double check. And I'm going to show you how to check and make sure things are right. When I look at this vertically, she was consistent. Can you guys look at this and see what I'm saying when I say vertically she was consistent? Do you agree? Vertically, she matched the 2 with the 7, and those are corresponding sides. And vertically, she matched the 21 with the 6, and those are corresponding sides. She was consistent with how she matched things going up and down. Where she became inconsistently is horizontally. Horizontally, she matched the 2 with the 21. 2's got nothing to do with 21, does it? They're not from the same shape, and they're not corresponding parts. Those do not belong together. So a quick and simple fix would be what? How could she fix this problem? She could flip the 21 over 6. That would be one way she could fix it. Or she could flip the other one. Or she could flip the 2 top ones. Or she could flip the 2 bottom ones. All right? So it's really easy to take something that's wrong and fix it. It's also really easy to accidentally do something that's wrong. And so you want to check it. So let's keep that in mind as we go forward. Now, before we look at this next page, guys, I got to tell you, for those who are working ahead, if I put this next problem in front of a 4th grader who had no idea how to solve an algebra problem, had never seen a proportion in their life, they'd probably be able to figure it out, okay? Because it's kind of simple. The numbers are really simple. For those who've worked ahead, you're probably like, this took me like 2 seconds. I didn't need algebra to do this, okay? And some of you are looking ahead. I hope you won't, but here's what I got to tell you. We're going to deal with some simple numbers in these next 3 problems. It's going to get more complicated than this, okay? So I don't want you doing the thing where you look at this and you're like, oh, I don't need to do this fancy proportion thing to figure this out because I can do it without that. That's cool. Good for you. I'm proud of you. I still want you to use the proportions because I want you to practice it while it's easy because eventually stuff's going to get more difficult. All right, so look at the next problem. Look at the next problem here. Would you agree with me that probably 4th grade you could look at this thing and figure out pretty quickly what x is? Yeah? How would you do it? Yeah, you'd be like, hey, this is twice as big as this, so this must be twice as big as this. What's x going to be? We all know it's going to be 12. Now, I want you to pretend you don't know that x is going to be 12, okay? And I want to practice doing it because here's the thing, guys. Eventually, it's not going to be 2 and 4. It's going to be 11.2 and 51.4. Okay? And you're not going to be able to look at that and figure out, oh, I just need to multiply this by, I don't know, 4.78 or something like that. Okay. So let's practice. While the numbers are simple, let's practice with all of our stuff here. Hey. Oh, hey, that's awesome. Thank you. Woohoo. All right. So let's set up a proportion. Here we go, guys. Stick with me. Remember, this is our learning target for today. This is the big thing. We're going to set up a proportion, and we need to get all 4 of those things in there. And the thing that I always focus on is x. Where would you all like to put x in our proportion? You want to go top left? It's kind of like we're reading a book. Yeah. That's a great place to put it. Let's go ahead and do that for this one. Now, in truth, it really doesn't matter. We could have put it anywhere. We could have put it anywhere. Now, I want you to look at that x in the picture, and I want you to put something underneath it over here that matches up with the x in some way. We got a couple options for things that match up with x. Tell me one thing that we could match up with x in this picture. We could use the 6 because x and 6 are both their corresponding parts, right? But I also heard 4. What do x and 4 have in common? They're on the same shape. So either one of those would work. I'm going to go with the 6 because that's what most people said when I asked the question. But those of you who want to go a little different way, why don't you try putting a 4 on the bottom and see if you can work the next part out on your own. Challenge yourself. And the goal is going to be, we want to get the same answer. And I think we will. All right, so I used x and 6. which means I still need to use 2 and 4. Now, if you're doing this and you're thinking a little different from me, but I need to use the 2 and 4, and I want to be consistent. So here I did x, which came from the bigger shape on the top. So which of those two comes from the bigger shape? The 4 does. So put it on the top, and then that puts 2 on the bottom. And before I move on, I have trained myself to double check this because I've screwed this up so many times that I just don't go on without double checking. Can I get your attention up here so I can show you how I do this really quickly? Look up here, please. Look up here, please. Awesome, thank you so much. Vertically, what do x and 6 have in common? They're corresponding parts. Corresponding parts. Vertically, do 4 and 2 have that same thing in common? Are they also corresponding parts? We nailed it vertically. Horizontally, what do x and 4 have in common? They came from the same rectangle. Horizontally, do 6 and 2 also come from the same rectangle? We're consistent vertically, we're consistent horizontally, we're good to go. All right, let's go ahead and cross multiply and solve this thing, and we will be done with our first problem. 2 times x is 2x. 6 times 4 is 24. Do one quick step of algebra to solve. Man, I wonder what x is going to end up being. It's, guys, it's 12. We got 12. Now, those of you who decided to be bold and try it a different way, did you get the same answer?
Yeah.
In fact, when you cross multiply, did you get the same equation?
Yes.
Did you also get 2x equals 24? There are 8 different ways you could set up this proportion, and you would still get 2x equals 24 for your equation. Or maybe 24 equals 2x. All right, any questions on that first one? All right, hey, this second one, I'm going to give you a little hint that may be useful to you. Now, some of you have this wonderful quality where you can take a shape like this and spin it around in your head, zoom it in, zoom it out, flip it, and all kinds of stuff, and know what it's going to look like. Most of us are not that way, okay? So if you are like me, and that's a little more challenging for you, we got tracing paper, all right? So you don't need to grab tracing paper. Let's just, I got you covered here. So what I would do is I would trace it. I'm going to put the 3 and the 6 on here, and then I'm going to start moving this around and see if I can get it to match up in the same orientation as this. Let me try flipping it. No, that doesn't match. What if I spin it? Oh, there we go. Yeah? Yeah. So rotation gets us there. Love that you're practicing that terminology. And what I'm noticing here is that the x matches with the 6 and the 3 matches with the 4. Okay? So I'm going to make note of that right now. X matches with 6. And I like to just circle them and draw a line between them. X and 6 are connected. Those are corresponding parts. And 3 and 4 are also connected. So sometimes they're going to give you 2 shapes and they're not in the same orientation. My strategy in that case is to trace one of them and force them to be in the same orientation, figure out what matches up with what. Okay? All right, it's time to do the thing, guys. This is the thing from our learning target. Can you set up a proportion that's got the x and the 4 and the 3 and the 6 all together? Give it a shot and go ahead and do your first step of cross multiplying. I'm going to write mine up here in a second, but I'm not interested in you just copying mine. I want you to try it on your own. You're going to know if you did it right if when we cross multiply we get the same thing. My first step will probably look different from yours. But after we cross multiply, we'll probably end up with the same thing, if we're both doing it right. Let's see here. I'm going to put my x down here just to be weird. I'll put that up here. X matches up with 6. 4 matches up with 3. And I'm going to cross multiply. All right, I hope you've had a chance to try it. If you're still working, that's fine. Don't look up here until you've gotten done with your cross multiply step. If you are done and you cross multiplied and you've got a 3x and a 24 equal to each other, then you did it right. You might have 24 equal to 3x instead of 3x equal to 24. But if you did that, then you did it right. If you had 4x and 18, then you made a mistake. You weren't consistent in how you set it up. Okay? All right, we'll solve it. If you haven't already. Let's solve it. 24 divided by 3, that's 8, isn't it? You got this? Did you solve it? Did you get 8? Nice job. Anybody have any questions on that one? All right, this is the third one of this type. Again, this is our, by the way, guys, we got these 2 more problems to do, but they're going to go fast. This is the main thing for today. We're missing something. If I want to try and set up a proportion, I need to figure out what that side is. Can you guys use the fact that the perimeter is equal to 60 to figure out what that missing side is? Do you all know what the perimeter is? How do you find the perimeter of a shape? You add all the sides together. We had some trouble on this. I have graded the first 2 pages of the test. And on the second page was the one where you had to set up the equation with the perimeter of a rectangle. And a lot of people only added up 2 of the sides to find a rectangle. Instead of 4, there's 4 sides. If you're doing perimeter, you've got to add up all 4 sides, right? Some people decided if it's a rectangle, then 2 of the sides are going to be equal to each other. That's true if that rectangle is a square, but that rectangle was not a square. Some people decided to add up 2 sides of the rectangle and make it equal to 180, which I can kind of see that one too, because we saw some equations like that. But when you add up, when you find a perimeter, you add up all 4 sides of the rectangle. We also know that opposite sides are the same, so that would be 21. So tell me, what do I got to put in? I got to put the same number here and here, and they need to all add up to 60. What's it got to be? It would be 9. And how'd you get it? I love it. Love it. I like that you're doing the subtraction. That's how I always think of it. I'm like, this is my total. I'm going to start taking away the stuff that I know. And then that leaves me with my leftovers. And 18's left over, I got to split it in half to make those 2 sides. Excellent work. All right, now that we know that's 9, can you go ahead and set me up a proportion and solve for x? You're going to use the x and the 9 and the 21 and the 3, but you'll have to figure out how you want to put them into your proportion. And then do me and yourself a favor and double check that you're being consistent both horizontally and vertically. I'm going to put my x over here. It is. It's super easy. You got to double check.
I told you 7. I was just thinking 2 steps ahead. Yeah, you said it's either 9 or 7. But like, you know, technically, that's technically different.
Is this right? 3 and x. 3 and x are from the same shape. 9 and 21 are from the same shape. And then horizontally, 3 and 9 are both the vertical, the short side. And x and 21 are both the long side. Okay, that is right. It didn't look right to me at first. 3 times 9, or x times 9 is 9x. 3 times 21 is 63. Are you guys getting 7? Hooray. Okay. Okay. Can we, guys, are you okay with me giving you the short version of number 26? All right, let me tell you what you need to know here, okay? The big thing is scale factor. We've seen this before with dilations, right? Every set of similar figures has a scale factor, but you need to know which one's the original and which one's the new. When we do scale factor, we always take the new size and divide it by the original size. I'm going to say new and old. That's going to be our scale factor. It's the new size divided by the old size. All right, and I'm going to go back to one of our previous examples to make sure we got this. You guys have all of that written down? All right, you're going to have to follow along with me because I'm going off the script here, guys. I want you to find me a scale factor for this, and I want you to assume that this is the original and this is the new shape. Find me a scale factor. Do it right up here. Scale factor would be equal what? Now to do this, I just need to find two sides that correspond, that match up with each other, and put them into a fraction. But I got to make sure I put the new size on the top and the old one on the bottom. So I could use, probably the smart move is to use the 3 and the 4, right? Which one will go on top? The 3 will go on top because it's the new one, and then the original was the 4. Scale factor is 3 over 4. Can you guys pause for a second, please? Scale factor is 3 over 4, which is equal to, what would that be as a decimal? 0.75. Now, check this out. I don't want you to miss this. This is important. Remember I said how the homework help's going to show you how to do these problems in a different way that only works 70% of the time? This is it. Oh, man, I really wish you'd pay attention instead of messing around with that calculator. Seriously. Thank you. Here's how they're going to tell you to do it. Let's say that they had put a y over here and they put a 7 over here. Now, if I asked you to do this problem right now, you would say, oh, no problem, Mr. Height. I'm just going to set up a proportion. I'm going to put y over 7, and then I'm going to put 3 over 4, and I'm going to cross multiply and solve it, right? Easy, right? This is how they would do it. This is how they're going to show you to do it. They're going to say, oh, just take the old side, 7, and multiply it by the scale factor, 0.75, and that'll tell you the new side. So there's a couple problems with it, but it does work. It does work. If you solve this proportion right now the way we've been doing, you're going to get the same answer, 7 times 0.75, and that is the correct answer. It's 5.25. Y would be 5.25. Which seems like that's way easier, right? But there's some problems. Sometimes you're not going to be able to find the scale factor because you don't have enough information. And I'll tell you the bigger problem is, what if your scale factor ends up being something like, well, what if we had gone the other way around with this? What if this had been the original and this had been the new? Then my scale factor would be 4 over 3. And what is 4 over 3 as a decimal? Is it 1.3? I heard 1.3 though. Is it equal to 1.3? No, but here's what's going to happen. I'm going to have people on the test, and it happens every year. Someone's going to be like, I'm not doing those proportions. Those are dumb. I'm just going to do 4 divided by 3 and put it in my calculator. That's 1.3. Close enough. Close enough. And then I'm just going to multiply this times 1.3, and that's going to get me my answer. And it's going to get you something very close to your answer, but it's not going to be your answer. Why? Because you rounded this off. Your scale factor is not 1.3. It's close to 1.3. It's not 1.3. And there's no button on your calculator to do 1.3 repeating. So you would have to do it. You'd actually have to use a fraction to do it that way. Guys, all this to say, would you please, if they ask you to find the scale factor, find the scale factor. If they ask you to find a side, would you please set up a proportion and solve it this way? Please do it this way. My students who use proportions get better grades on their tests. They make fewer mistakes on their assignments, okay? Homework help's going to try and get you to do it a different way. Use proportions, all right? All right, enough of that. Last question. We're going to make this really quick. Al took this angle, and he said, I'm going to make it twice as big. He used a scale factor of what? If it's twice as long, what's a scale factor? 2. Everything got multiplied by 2. Whatever this is, if this was 1.2 centimeters long, it's now 2.4 centimeters long. This one looks like it's a little longer. It's 1.3. Now it's 2.6. This original angle was 60 degrees. What's the new angle? 120?
No, 60.
Why would it be the same? Everything else got multiplied by 2.
You're not changing the.
It's still like the same shape. It's the same shape. Thank you.
All right, I'm hearing some good explanations. First of all, if it was 120, that wouldn't make sense because this angle clearly isn't bigger than 90, right? And if I trace this, you'll find that they are actually the same. So why? What did we say about dilations?
Same shape.
They keep the same shape, and shape controls angles. Angles control shape. So same shape means the angles aren't going to change. When we dilate something, it doesn't change the angles. It changes all the lengths, it changes the sides, does not change angles. So let's write that down because it's a common misconception. Dilations, they can change the size, but not the shape, which means not the angles. Right? If I've got a triangle and it's a right triangle and I dilate it, I still want the new one to be a right triangle. Otherwise, it's not keeping the same shape, which means that original 90 degrees still better be a 90 degrees. We can't turn a 90 degrees into a 180 degrees. That would be weird, a triangle with a 180 degree angle in it. That's spicy. Okay, folks, you guys did awesome today. I think so, but I want you to go back and grade yourselves. Looking back at our learning target today, if I give you two shapes and I tell you these two shapes are similar, and this one's got an X in it, and this one's got some numbers, 2.7 and 8.1, and you got a 3.4 over there, do you feel like you would be able to set up a proportion that you could use to solve for X? That looks a little more complicated than what we did today, and you're going to see some stuff like that later on. For right now, it'll probably be a little bit easier, but that's our main learning target. Would you be able to take this and turn it into a proportion and then cross-multiply and solve for X? If you did, then you've met our learning target for today. I'd recommend giving yourself a 2 or a 3 if you're feeling good about the problems we did today, because they are going to get a little bit harder. But if you're already convinced, like, oh, I don't care, bring it on. Put decimals in there, put whatever you want in there. I'm going to be able to do this thing. Give yourself a 4, okay? All right, guys. Your assignment for next class is 3.1.3. You got some time. Please utilize this time to ask me some questions if you got questions. You guys did an excellent job. Thank you for holding those side conversations. I appreciate you guys. Thank you, thank you, thank you. Get busy. Let me know how I can help.